All right, thanks for joining me today for a new announcement, or rather training on a new product that has really been a long time coming, the new formulation of the X-tra Lube Grease. Now, this was something that had been brewing for a while, and the X-tra Lube formulation itself is something that our customers have come to know and really like over the years, and that formulation has changed. Some people might say that the old X-tra Lube could not be improved upon, but we believe that the new formulation of X-tra Lube meets and surpasses the old formulation in a number of key ways. So today we're going to review the new X-tra Lube Grease formulation, and by the time we're done, we're confident that you will agree it's something that you and our customers are really going to like. So in order to do this, what we're going to do today is we are going to cover these main points. Similar to the training that we've done on the reformulation for X-tra Lube Concentrate, we want to cover the transition from the previous grease formulation to the new formulation. That means talking about why we had to change and what we were looking for when we were investigating the options for that change. We will cover the features of the new X-tra Lube Grease product, and we especially want to cover how the new formulation compares to the old formulation, especially with respect to its performance. Now, as we said before, we should, in talking about this, we really need to consider how we as a sales team want to communicate the value of the change with our long-standing customers. Specifically why we had to make the change and why this new formulation is a good thing. And then for when we're talking about this for new customers, we have to talk about it a little differently. We will need to know how to present X-tra Lube Grease as a high-value grease that will meet their needs. These new customers, so to speak, they don't have a meaningful memory or working knowledge of the old X-tra Lube Grease formulation, so they're really not going to need to know how the new formulation compares to the old one. What they need to know is why this thing called X-tra Lube Grease is better than the other things that they can get out on the marketplace. So whenever we talked about the X-tra Lube family of products, we always have to include the X-tra Lube Grease product because it has the same effective backbone as the oil additives. Now, that's true whether you're talking about the old X-tra Lube or the new X-tra Lube. The old X-tra Lube used this thing called MBL. And so when we knew that we had to transition away from using MBL, we knew that this was going to mean a reformulation not just of the oil additive but also of the X-tra Lube Grease as well. So, looking at the old X-tra Lube, the old X-tra Lube Concentrate formulation, just to review, the old product used this thing called MBL, which was called metal-based lubricant, and it contained copper and lead that filled in surface wear and really reduced friction. Really did a great job of not only providing really good extreme pressure protection, but also providing really good residual protection as well. But we ended up having to switch because there were some issues with not only with respect to the cost of the ingredients, but also manufacturing capabilities. And so this led us to reformulate the entire X-tra Lube line. Now, in order to understand the X-tra Lube Grease, in order to get a full picture, so to speak, of what it is and why it's a good thing, it's helpful to start at the beginning. The first thing we need to talk about is that the new X-tra Lube Grease uses a completely different kind of base grease. It uses a calcium sulfonate grease instead of a lithium complex grease. Now, most non-synthetic greases are made through the same basic process. You take an acid, which in this case is a fatty acid, and you add it to a base. And when those two react, what you get is you get this thing called a soap, and you get water. That is basically how you make household soap as well. You take vegetable or animal fat, and you react it with lye, which is the base. The fat is the acid because all fats are made up of these things called triglycerides, which are 3 molecules of a fatty acid attached to 1 molecule of glycerol. Now, obviously, when you're making grease for industrial use, things start to get a little bit more complicated than just animal fat plus lye equals soap. You're going to use more complex kinds of acids and bases to make the kind of grease that you need to make. So you get this thing, you get this creation of this soap matrix, and the soap matrix is analogous to a sponge. They take base lubricating oil, and they add it to this soap matrix, and what you get, or what's formed, is this homogeneous suspension, or this homogeneous colloid, so to speak. The soap matrix acts like a sponge, and it traps or holds the lube oil. Then you take that, and you start to add thickeners and various additives. Now, when you talk about different kinds of greases, and whether you're talking about, a moly grease or a calcium sulfonate grease or a lithium complex grease, typically what identifies the grease is the kind of thickener that's used to help the soap matrix hold the lube oil. Now, the old X-tra Lube Grease was manufactured by combining the MBL package with an additional additive package and blending both of those into a lithium complex base grease. Now, lithium complex grease was used for many years because lithium grease is a kind of a workhorse grease. It's a good all-around base grease that does well in a number of important areas. It's got good performance characteristics, first of all. It plays well and is compatible with a wide variety of other greases. We're going to talk about that towards the end because that's an important thing to keep in mind. Lithium greases have good shear stability. They have fairly good temperature range. They have good pumpability. They score well in all the things that you need to consider when you're selecting the right kind of grease for an application. And just as a side note, lithium greases are the most popular base greases used around the world because they are a good all-around grease that does well in so many areas. Now, why we needed to transition? Well, we had to transition the X-tra Lube Grease formulation from the old to the new for many of the same reasons that applied to the transition for the X-tra Lube concentrate. First of all, constituent costs. Unlike the oil additives, the grease has 2 parts to consider. You have the costs or the constituent costs that go into making the MBL, and then you also have the cost of the base grease as well. So you had, on one hand, you had the issue that the MBL constituents, the copper and lead and some of the other chemicals, were rising dramatically in cost. So it was really making that part of the formulation cost skyrocket. But then, in addition to that, costs for lithium around the world have been steadily increasing and will continue to increase in coming years because of a worldwide demand for lithium in batteries for electronics. So we were faced with a situation where not only is it much more expensive to make the MBL backbone of the grease, but it's much more the base greases themselves were really rising in cost significantly. Second thing, manufacturing costs and equipment. It's actually even more time-consuming and more labor-intensive to manufacture X-tra Lube Grease as it is to manufacture the X-tra Lube concentrate oil additive. And when you're comparing product sales to the cost of, for example, having to replace the manufacturing equipment, there ended up being just no way to justify the return on investment if things stayed the way they were. They also had the same kind of manufacturing time considerations. It says inordinate manufacturing times. We had at one time discussed with some large grease manufacturers the possibility of doing toll manufacturing. That is, a common practice in industry. What we found, though, was that When you're talking about creating grease, you use large grease kettles. You have to use large amounts of heat. You have specific processes that do not really lend themselves very well to the addition of a unique set of ingredients like the copper and lead. Basically, what we found was that toll manufacturers could not manufacture it for us because they would have to dedicate equipment and dedicate lines just for the X-tra Lube Grease, and nobody really wanted to do it. So we did not have that option to fall back on. And then the last thing, price competitiveness. Even though the performance of the X-tra Lube products was superior to virtually anything else out there, when you look at the sheer cost, the overhead, the time needed to make them, meant that they really just were not cost competitive in the B2B marketplace. So all these factors made it evident that we needed to reformulate the X-tra Lube products and replace them with new formulations. And we realized that if we could not successfully do that, we were probably going to end up having to drop the X-tra Lube line altogether, as we had passed the tipping point where the total costs of having it was more expensive than the tangible value that we would get from keeping the products in our line as is. So when we were looking for alternatives, we knew that there had always been a high level of expectation with regards to the quality and the performance of the X-tra Lube line. This was true of the oil additive. This was especially true of the grease. So we needed a high-quality replacement. And the search for a replacement formulation was based on a list of essential characteristics. We needed, at a minimum, certain things in order to go with a reformulation. First thing was great performance, high performance. As with the oil additive, any possible grease replacement had to offer market-leading performance, because there would be no point in having a replacement if it was just going to make us one of the pack. That wouldn't be worth it. What did we think this should look like? What did high performance look like in this case? Well, the important measures, performance measures for grease, would be ones that illustrate or demonstrate how well the grease protects under both normal conditions of use and any reasonable extremes that the user most likely would need protection for in the course of use. So we would look at things like the dropping point, the 4-ball EP wear test performance, copper strip corrosion, worked penetration, water washout. We were looking for grease that would give excellent performance in those areas. And then the second thing was it had to be easier and more cost-effective to manufacture. The new formulation, new grease formulations would not do us any good if we could not make them in a more efficient and more cost-effective manner. And this is especially important for the consideration of having someone else manufacture or fulfill packaging for us. So this was an essential consideration. And this brings us to the new grease formulation. We need to be able to understand how it has changed from the traditional X-tra Lube Grease, the old X-tra Lube. And as we examine the documented differences between the old and the new, we may start to be able to see how best to explain its value and how to explain the value of the change to customers who might be used to the previous formulations. So comparing the old versus the new, what do we see? First difference, the first difference that you would notice or that you would look at are qualitative ones, things like color and consistency. So first, both the old and the new X-tra Lubes are both grade 2 greases. That means that they are the same thickness rating. And thickness is documented with a cone penetration test, and they both have similar thicknesses, so they both score similarly in those areas. Visually, the biggest difference will be the fact that it's a different color. The new grease is a green color. The old X-tra Lube Grease, because of the color of some of the MBL constituents, tended to be a darker gray. Doesn't have anything to do with its performance characteristics. It is just a different color. The other big change, besides visual color, is that both the base grease and the additive backbone have changed. The old X-tra Lube Grease contained MBL in a lithium complex base grease. The new X-tra Lube Grease uses a calcium sulfonate background along with a calcium sulfonate base grease. So it is the calcium sulfonate itself that effectively replaces the MBL in the grease's functioning. So how does it work? Now recall from earlier discussions of the old X-tra Lube that the old MBL worked in a different way than the new calcium sulfonate does. The old MBL, remember, would have copper and lead particles that would fill in the surface wear and the surface irregularities and the scratches and the grooves on any metal surface. And so they would actually change shape. They would fill those in, and so they provided really good enhanced EP protection through the inherent slipperiness, so to speak, of the two metals. So, and over the years, we all learned how to explain how the old MBL and the old X-tra Lube worked. Now we have to change things a little bit. We have to explain that the new calcium sulfonate in the new X-tra Lube Grease works a little bit differently. The calcium sulfonate particles in the new grease, when you expose them to the heat and the pressure of a lubrication environment, they don't fill in the wear. They actually form a layer of protection across the surface of the metal, and that is known within oil chemistry or oil science, tribology, as boundary lubrication. Boundary lubrication then ends up strengthening the oil film itself, and you end up with superior EP protection. One thing that we mentioned when we were talking about the oil additive X-tra Lube, we mentioned that this boundary lubrication mechanism is the same kind of mechanism that ZDDP used for many years. ZDDP, zinc dialkyl dithiiophosphate, was the go-to extreme pressure protection additive in motor oils for decades, and it was the go-to one, or the gold standard, because it did a really good job of protecting against wear in extreme pressure situations, and it did it by exactly this same mechanism. So the calcium sulfonate in X-tra Lube Grease protects in exactly the same way that ZDDP would protect in motor oil. Now, recall some of the other benefits that the new reformulation brings. Remember that calcium sulfonate began being used in grease more popularly in the 1980s. It's been around for a long time, but started being introduced in grease in the 80s. But even before the 80s, when you get to the 70s, they were introducing it into lubricants to provide anti-corrosion and detergency benefits, because calcium sulfonate itself is an excellent detergent. It does a really good job of cleaning lubricated surfaces, removing things that might build up in the course of a lubrication situation, so to speak. Cleans those surfaces, helps protect them against buildup of the kind of deposits and contaminants that tend to form in those kind of situations, and if they're not removed, they're going to cause damage to those surfaces. So the new X-tra Lube Grease provides these kinds of benefits. Now, let's look at how the new grease formulation compares to the old grease formulation in its documented specifications, which is what you see on your screen here. So if you were to refer to a specification sheet of the old grease and compare it to the new grease, what you would find is basically the two columns that we have here on the screen. You would see in a typical oil technical data sheet, you'll find performance specifications of these kinds. So what we want to do is we want to go through these. We want to see First of all, we want to explain what each one of these means, and then we want to compare the results, so the performance of the old grease with the new grease. So let's do that. Let's start at the top, NLGI grade. NLGI grade is just refers to what we referred to earlier, the thickness of the grease. As we said, they're both number 2 greases, so there's no change there. Color and thickener type have already been discussed. The new X-tra Lube Grease is a green grease that uses a calcium sulfonate thickener. The old X-tra Lube Grease was dark gray and used a lithium complex thickener in its base grease. Base oil viscosity is also not something that you really need to worry about. That is typically put on there as part of the oil specification, but it's more descriptive than it is an indicator of performance. The first really important one that we look at is dropping point, 5th from the top, listed in degrees Fahrenheit. Dropping point is really the first key performance characteristic that many people look at. The definition of dropping point, it's a temperature. And dropping point is the temperature at which the grease passes from a semi-solid state to a liquid state. You could also think of it as the temperature at which a grease becomes fluid enough to actually drip. And so dropping point basically indicates the upper temperature limit at which a grease will retain its semi-solid structure. Now, some people confuse dropping point with maximum operating temperature. Dropping point is not the maximum temperature at which a grease may be used. That maximum temperature is always lower. Grease manufacturers never recommend that you use grease all the way up to the dropping point. Typically, the upper operating limit for a grease is recommended to be 100 to 150 degrees below the dropping point. So, dropping point is when it changes state, goes from semi-solid, grease-like, to liquid. In order for a grease to change state like this, one thing that has to happen is that the soap matrix has to break down, has to degrade. So that tells us that the kind of thickeners used to make the grease will help to dictate how high its dropping point is. The kinds of thickeners that you might encounter are calcium and lithium and aluminum, barium. There's also polyurea. There's even clay, like bentonite clay. You'll see greases made with these different kinds of thickeners. You may also come across 2 greases that might seem similar. One might be called a calcium grease, and another might be called a calcium complex grease. Well, what's the difference between those two? They're both calcium, right? Well, not exactly. The regular calcium grease is known as a simple soap. They took a fatty acid, they reacted it with a metal hydroxide, which is the base, and in this case it's calcium hydroxide, and they formed a simple calcium soap, which is then used to make the grease like we discussed earlier. But sometimes they might take that same fatty acid, and they might take the same metal hydroxide, but this time they might throw in an additional acid into the mix, what they might call a short-chain organic complexing acid. Long and short of it is that when you do that, you get a calcium complex soap. And the reason why we're bringing this up is because calcium complex soaps can be used to make greases that have much better or higher temperature properties. So, going back to the old versus the new. Notice that the old X-tra Lube Grease in its specifications has a dropping point of about 370 degrees Fahrenheit, but it says minimum. So 370 minimum. Since it's made with a lithium complex grease, we know from a grease chemistry standpoint, that lithium greases top out with their dropping points at around 500 degrees. And that is a standard property of lithium greases. You cannot have a lithium grease that has a dropping point that is significantly above, let's say, the low 500s, maybe 525, somewhere between 500 and 525. Now remember, we said that the operating temperature, or the maximum operating temperature, was typically 100, 150 degrees below that. So that means the effective operating temperature range for the old X-tra Lube Grease with lithium complex base grease would be between 350 and 400 degrees, which is fairly good performance there. The new X-tra Lube Grease has a dropping point that's more than 100 degrees above the old formulation, 605 degrees Fahrenheit. And so that means that the operating temperature limit for the new grease is also 100 degrees higher, and that is a significant difference. So the dropping point is higher here because the calcium sulfonate soap complex in the base grease is more stable at high temperatures than lithium soap complexes are. So that is advantage number one for the new formulation. Higher dropping point, which of course leads to higher operating temperature range. Okay, second thing we want to look at is worked penetration. Now you see three measurements there that are labeled as worked penetration. There's a 60 stroke, there's a 10,000 stroke, and there's a 100,000 stroke. Worked penetration tests document a property of the grease known as shear stability. And shear stability is one of the essential characteristics of any grease. Wherever you're using grease needs to maintain its consistency under high shear conditions over as long a period of time as possible. So they use the ASTM D217 test to document how the grease's thickness may change over time. They take a sample of the grease, they put it into a special machine, and they work it. They essentially, they turn it over or they work it for 60 strokes, and then they measure the thickness. And then they work it for 10,000 strokes, so a much longer period of time, and they measure the thickness. And depending on if it's specified, they will then work it for 100,000 strokes, and they will test the thickness, and they will see how the thickness of the grease changes within the 3 points. So the basic rule of thumb here when you're interpreting results is that the higher the number on the work penetration test, the thinner the grease is. Now the reason that is because the work penetration test is the same one that they use for what they call cone penetration, which is what they use to gauge the grade, the NLGI grade. And what they're doing is they're taking a weighted cone, essentially a cone-shaped weight, and they're dropping it into a vat of this grease, and they're seeing how far down it sinks. A thicker grease, it's not going to drop down as much, right? A thinner grease, it will drop down more. It will penetrate more. So that's why a higher score on this test means a thinner grease. Now, when you're comparing these scores, you want the change in the penetration between the 60 and the 10,000 and the 100,000 strokes. You want it to be as little change as possible. If the change is small, that means that the grease has essentially, I guess for lack of a better way of putting it, has held up under high shear conditions better than not. So if you compare the old X-tra Lube Grease and the new X-tra Lube Grease with respect to changes in the work penetration, you see some significant differences. If you start at 60 strokes penetration, well, they're both pretty much the same. And you would expect that because they're both number 2 greases, 284 versus 280. When you work it for 10,000 strokes and then you check the penetration, you see that the X-tra Lube Grease has gone up or lost about 18 points. It went up from 284 to 302, which is okay. But when you're comparing the new grease, that one went from 280 to 287. That's only 7 units change. That's a significant difference. But then when you also look at, you go to 100,000 strokes next, and you check the thickness, the old grease goes up to 319. So from 60 to 100,000 strokes, you have gone, let's see, turn it at 35. You had 35 change. And that 319 is actually right on the verge of going from a number 2 grade thickness to a number 1 grade thickness. It's right on that borderline. And when they're recommending greases, one rule of thumb that they look for when they're looking at the difference, the change in penetration, is that a good grease is going to lose less than 1 NLGI grade on this test. Well, the old X-tra Lube grease still stays within those parameters, so it's still graded as a quote-unquote good grease. But when you look at the difference with the new grease, at 100,000 strokes, it's at only 301, which is a change of 21 grade units instead of 35. So there is a significantly better performance in the work penetration test that the new X-tra Lube grease has. So that is advantage number 2. Advantage number 1 was better dropping point. Advantage number 2 is better shear stability. The next one we look at is the one below that, oxidation loss. This test, which is documented as ASTM D942, it documents how resistant a grease is to oxidation under static conditions. We know out in the field that when you're using grease at higher temperatures, let's say temperatures that are above 200, 250 degrees, we see that for every 20 degrees Fahrenheit rise in temperature above that floor, the oxidation rate of a given grease actually doubles. And we know that many lubricating scenarios have constant temperatures that are much higher than this. Now, if a grease can't resist oxidation, then bad things happen. If it can't resist oxidation, it will harden and it will cake prematurely, essentially breaks down. And that then destroys the base oil and inactivates its lubricating properties, and that can be really, really bad in most situations. So you don't want that to happen. So you run an oxidation loss test. The oxidation loss test tells you how well it resists oxidation. Now, how the test is run itself, they take a grease sample and they actually put it in a pressurized oxygen chamber that's filled with oxygen, and it has a given pressure, a given PSI. So if you know the pressure in there, because it's a sealed chamber, you know that there's a finite amount of oxygen in that chamber, so to speak. And they raise the temperature and they basically let the grease sit there and oxidize or react with the oxygen in that chamber for a certain amount of time. That's why you see oxidation loss PSI 500 to 1,000 hours. Now, what happens is that if the grease reacts with the oxygen, it's going to use some of that oxygen up over the course of the oxidation reactions that are taking place. And when that oxygen gets used up, it causes the pressure to go down because there's now less oxygen, right? There's less oxygen in that chamber because some of it has reacted with the grease. And so what they're going to do is they're going to run it for 500 hours or 1,000 hours, and they're going to measure any change in PSI, any pressure change. And so if you look at the difference in test results between the old grease and the new grease, you see a significant difference. The old grease lost 10 PSI after 500 hours on the test. The new grease, they doubled the time length to 1,000 hours, and they got even less loss, only 8 PSI loss. That is a significant difference, and that is advantage number 3 for the new X-tra Lube grease. Better oxidative stability to go along with better dropping point and better shear stability. Okay, number 4, copper strip corrosion. This is a standard test within the industry. Really, it's a standard test whether you're testing fuel or lubricants. And it involves, you take a copper strip and you expose it to a substance, whether it's fuel or oil. You expose it to a substance over a period of time, and that strip will change color based on if there's any corrosion that's going on. And then they take it and they compare it to a color chart, basically, and they give it a grade, a copper strip corrosion grade. And you can see that both the old grease and the new grease give the same results, a 1B. That's that's good. And the reason why a copper strip corrosion test is important is because you don't want, whether it's fuel or whether it's lubricating oil, whether it's grease, you want it to help surfaces resist corrosion. You do not want it to be corrosive itself to the fuel. And to be fair, it is kind of rare to find an oil or a lubricant or a fuel that fails this copper strip corrosion test. So there we are. Next one is water washout. Water washout is one of the grease specification that is fairly commonly cited within the grease literature out there. Many industrial applications have high water exposure. This is especially true for many industries that use bearings. So in those situations, you need whatever grease that you're using. It needs to resist softening. It needs to resist reaction or emulsification with water, because if it can't do that, then any water exposure is actually going to wash it out of, like, let's say, the bearings. And anytime when the grease gets displaced by water exposure, then you've got a compromised lubrication situation, and serious results can ensue. So the water washout test is used to evaluate how well grease resists this. They take a bearing housing and they pack it with a given test grease, and they put it, they warm everything up to a specific temperature so everything is standardized and controlled. Then they rotate the bearing at 600 RPM, so it's going around 10 times a second basically. And at the same time, they're adding water at a controlled rate, 5 milliliters per second. And they do this for 1 hour. Then they stop the test. They dry everything out. They put the bearing pack in an oven. That's about 170 degrees for about 16 hours. So that helps dry everything out. They then cool it, and they weigh the whole thing to determine the amount of grease that was lost during the water washout scenario. So comparing the old grease with the new grease, what you can see is that the new X-tra Lube Grease loses less than half of the amount that the old grease uses. And so that makes advantage number 4, better water washout performance, to go with the previous 3. Remember those? Dropping point, better shear stability, and better oxidative stability. So already you've got 4 major things that show that the performance of the new X-tra Lube Grease is significantly better than even the old grease. EP and wear tests, that's the last 3 results listed. These are tests that document extreme pressure and anti-wear protection properties of given grease. These are documented through a couple of different kinds of tests, the Timken load test and the 4-ball EP test. So the Timken load, sometimes you hear it referred to as Timken OK load. What that is, that test is actually the one that most closely matches the traditional friction brake machine test that you might see referenced. In executing this test, you have a standardized bearing, a Timken bearing, and it's rotating at a high speed, and then it's brought into contact with a steel block that has a load that's being applied to it. And the load is constant, it's standardized, so that you can control or standardize how this test is run. So it's in contact with it, and they're flooding the contact area with lubricant. And when you see the result, this OK load, the OK load, as they call it, is the highest standard load at which the spinning bearing, remember the bearing that's spinning, produces no scoring mark on the test block while producing a uniform wear scar. So it is one way to measure lubricant performance under load conditions. Now, for the first time, what you see is that the old X-tra Lube Grease does perform better on that test. It has a 55 kilogram versus a 29.5. So we've had 4 essential properties where the new grease pretty much blew the old one out of the water, but then all of a sudden we're seeing, well, the old grease, at least on the Timken test, seems to be protecting better. Well, on that test alone, yes, but we also have the 4-ball EP test to consider, and if we understand the kind of results that go on this, we start to kind of flesh this picture out a little more. Now, the 4-ball wear test, it's been discussed before. It's a standard test in the industry, and in order to run it, basically they take 4 steel balls, and they rotate them against each other, basically, in a sump that has lubricant in it. And they're exerting a force from on top through an arm or apparatus, kind of a spinning arm, so to speak. They're basically exerting force on these balls. So they exert a specific standardized amount of force. They rotate the balls for a specific a standardized speed for a specific amount of time, and then they stop it, they take the bearings out, and they look to see if there's any wear scars that have been formed. And if there are, then they measure them. And then they put the balls back in there, and they run the test again. And they repeat this at standardized intervals of load, 8 kilograms, 15, 30 kilograms, 50, 60, 7 kilograms, 100, 120. They keep increasing it incrementally until you get to the point where there's too much load and the lubricant can't handle it and the balls weld together. So from this you get certain points of data points that are generated. And what you can see here is you can see 2 things, a load wear index and a weld point. All right, so load wear, let's do the second one first, load wear index, not load wear index, weld point. Well, the weld point, measured in kilograms, is the last measurement, it is the measurement at which the balls weld together. And the new grease has a higher weld point than the old grease. So the new grease is 620, and the old grease is 500. Now, if you know how these tests are run, one thing you keep in mind is that what actually probably happened is that the actual welding point for whatever grease we're talking about, whether it's the old grease or the new grease, the actual welding point was in between the previous load and the weld point load. And what we mean is that if you look at the increments, the 2 increments actually are 500. They run a they run a load test at 500 kilograms. And so what happened is that at 500 kilograms, the old grease, the balls welded together. They stopped the test. When they tested the new X-tra Lube Grease with the calcium sulfonate, they ran the test all the way up through all those load increments, and they got up to 500. When they got up to 500, the balls didn't weld. They were able to keep going. The next load that's specified in the test parameters is 620. And so they ran it at 620, and the balls welded together. So if you get what I'm saying, you'll see that the actual weld point was somewhere between 500 and 620. And that is a useful thing to keep in mind if you're ever having to explain test results, whether it's for X-tra Lube Grease, X-tra Lube concentrate, or if you're comparing other kinds of lubricants. It's useful to be able to explain the significance of what these things mean, and you can better do that if you know how this test is run. Then the 4-ball EP load wear index. Load wear index is a mathematical calculation where after they have finished running the test, they've gotten the weld points, they've gotten last non-seizure load, which is the load that was previous to before the weld point. They've completed the test. They then take all the scar measurements and they plug in everything into a mathematical formula. And what that gives you a load wear index number. And the load wear index number kind of expresses how well the lubricant protected from start to finish. So it's not just, how many kilograms of force can you exert on that? Because even though that can be valuable, that doesn't tell you everything you need to know about how well that grease protects or that lubricant protects. You wanted to protect all the way through the loads. You wanted to protect at medium load. You wanted to protect at low load. You wanted to protect at high load. That's before you get to the weld point. So some people make the mistake of just focusing on the weld point, and that is not what you want to look at alone when you're trying to judge lubricant performance. So comparing the old and the new X-tra Lube Grease, what you see is that the new grease does have a higher weld point. That's good. The old X-tra Lube Grease actually has a higher load wear index, 93.5 versus 80. Now, at that point, you're like, well, the old grease is better. And since we just explained the significance of the load wear index, we'd say, yeah, the old grease was really good. But remember, people aren't choosing whether to buy the new X-tra Lube Grease or the old one. They're having to make a choice between the new X-tra Lube Grease and another kind of grease that's currently being sold. And even though we don't have it up on the screen, a typical lithium complex grease is going to have a load wear index somewhere in like the 40s, maybe 50, not much above that. So the new X-tra Lube Grease really blows away those kind of greases when it comes to load wear index because it has a load wear index of 80. So we have seen performance comparison of the old and the new grease formulations in pretty much 6 key areas. And if we're looking at all of this evidence, we are really forced to conclude that the new X-tra Lube Grease outperforms previous one in just about almost in every key area except for one Timken test and one load wear index test. So all in all, you would be forced to conclude that the new X-tra Lube Grease is significantly better in a number of really important ways over the old grease. So it's a better grease that we're transitioning to. All right, last big thing that we're going to talk about here, and it's something that kind of gets overused when people are talking about industrial grease use. That's the issue of grease compatibility. Grease compatibility can be critically important. You really have to get this one right because if you don't get it right, you will have a lubricant failure, and the cost of that can be pretty high. So compatibility issue comes into play when you're selecting a grease for use that might be different than a grease that you were using previously. Now, when you're transitioning from a previous grease to a new grease, what you're going to want to do is flush out the old grease. And typically what they'll do, they'll try to clean it out by basically injecting new grease into the lubricating space, and it will try and displace the old product. Now, what's the point of this? Well, if those two greases are incompatible, then you have a much higher risk of grease lubricant failure, which leads us to ask what makes a grease compatible or incompatible, and which specific ones work well together and which specific ones don't. Well, to understand the answers to these questions, you first have to harken back to remembering what grease actually is. At its heart, remember, grease is a heavy base oil, the lubricant, which is combined with some kind of soap thickener, and the soap thickener traps the lubricant oil and essentially makes the lubricant oil thick and stringy enough that actually stays in place when you put it into an area where there are moving parts. And when you have, when you use the term soap in this context, remember, we're not talking about, the kind of soap you wash your hands with. We're talking about a class of compounds that result from reacting an acid and a base together. And so in the case of making grease, remember, they take that fatty acid, they introduce a metal base, or some other kind of complexing agent. They react that with the base like sodium hydroxide, and they get this soap thickener that they use to manufacture grease from. So, mixing incompatible greases can have dire consequences. If two greases are incompatible, what's going to happen when they come in contact with each other in a lubricating environment, then they will react together, and they will cause the base oil to separate from the thickeners. When this happens, the base oil doesn't have anything holding it in place anymore, and so you get oil oozing or running out of an area where it was applied. And you can probably guess the bad things that follow from that. So, which greases are compatible and which greases are not? If you want a general rule of thumb as to whether two greases will be compatible, they are considered to be compatible if certain specifications of both greases are similar to each other. Now, recall that grease performance can be gauged by examining their specifications to give you an indication of performance. Some specifications like copper strip corrosion or oxidative stability, those are important, but they don't really meaningfully affect compatibility. But there are three other specifications that you would want to examine because they give important indications of whether two greases are compatible. First one's dropping point. If the dropping point of the two greases are similar enough, if they're similar enough, then when you mix them together, the overall dropping point of the mixture doesn't change all that much, and that's good. You want the overall dropping point of the old grease and the new grease mixed together to stay close to what it was before. So you want dropping points to be similar. Second one is mechanical stability. You want the mechanical stability of the grease mixture to be as close as possible to the mechanical stability of the two individual greases themselves. Hence why you want scores like the worked penetration test of the two greases to be similar. That's number two. And then number three, the worked penetration. When you store the grease mixture, when you expose it or use it at elevated temperatures, the elevated temperature is going to affect the consistency or the thickness. You want the thickness grade to stay within the range of change for the individual greases themselves. So you want dropping point, you want mechanical stability, and you want worked penetration. If you've got two greases, you want those three specifications to be as similar as possible. If you have that, then you should not have compatibility issues. Now, in situations where it is, really absolutely critical to make sure that you're on the right side of this issue, typically what will happen, a customer will actually, they won't do it by trial and error. They will actually contact the grease manufacturer. And the grease manufacturer will do bench testing of the specific greases in question to confirm those points. So it should be clear that it is important to get compatibility right. And in order to get it right or to be on the right side of the issue, it helps to have something like a compatibility chart, which typically looks something like this. Now, what you see is on the y-axis on the left, on both the x and the y-axis, you have different kinds of greases. Now, back in the old days, the most common thickeners that were used to make grease were simple soaps or clay. And so in those old simple days, compatibility was pretty easy to determine. Greases made with soaps from, like simple aluminum or calcium, they were compatible with each other. Clay greases were not compatible with those. So far, pretty simple. Today, you got a lot more choices, and so you have a lot more complexity to the issue. And so you need a compatibility chart like this to give you a good idea of which kinds of greases play well with each other and which kinds do not. Now, one thing that you will see on the chart if you look at it, if you find polyurea greases, which are at the bottom and the right, if you look at the X and the Y axis, you'll see that polyurea conventional and polyurea shear stable. What you see is polyurea greases seem to have the most compatibility problems, especially the polyurea conventional. In fact, the polyurea conventional is what we're talking about, not the shear stable. You see all those I's. I means incompatible. C means compatible, and B means mostly compatible. Decent enough. So B and C is okay, but I is what you don't want to see. You got a lot of I's when you're using conventional polyurea grease. Well, why is that? What is it about polyurea grease that causes it to have these issues? That typically comes from the fact that polyurea greases today can be made from a wide range of different components. And they're reacted together, and they form something that kind of falls under an umbrella classification being called polyurea grease. So not all biodiesel fuels are the same because they're made from different kinds of feedstocks, not all polyurea greases are exactly the same. That's why there's a lot more variance in their compatibility with other types of greases than what you might first suspect. So conventional polyurea greases have lots of incompatibility problems. On the flip side, shear stable polyurea greases are compatible with just about everything, and that's because they tend to be more synthetic. So you know the components that are going into that. Looking at some of these other greases, remember we said lithium complex grease was the most popular grease around the world in the marketplace. And one reason is because it's compatible with lots of other types of greases. Plays well with everything except for clay, barium complex, and the aforementioned conventional polyurea. Now, the new X-tra Lube Grease, calcium sulfonate. If you look at its compatibility issues, it has those same advantages. It has broad compatibility with many other types of greases. And its exceptions are for many of the same ones as the lithium complex. You've got the clay grease problem, you've got the conventional polyurea issue, and then you've also got incompatibility with calcium complex grease as well. So the takeaway here is that the new X-tra Lube Grease doesn't have any broad compatibility problems with most of the other greases that you'll find in the marketplace, and so that is a good thing. So wrapping this up now, we've gone over the technical aspects of this. Now let's move out a little bit and get less technical and talk more about sales issues. You can use it in just almost any application that you would use grease. Again, just check to make sure that there's not any rogue compatibility issues. But by and large, anywhere that you're going to use grease, you can use X-tra Lube Grease in. When you talk about handling of it, proper handling of it's pretty simple. It's not a food-grade grease, so you can't use it there. It does not have the same concerns with magnetic interactions that the old grease did, because the old grease had two different kinds of metals in it. The new X-tra Lube Grease does not. So it eliminates those concerns as well. And so, to wrap this up, doing a comparative review for X-tra Lube Grease. How does the new X-tra Lube Grease compare to the old? Remember, it has a better temperature range. It's more stable. It's better performing against water washout, and it has it's better oxidation stability as well. It's better shear stability. And those two things go into when we say more stable. And comparable EP protection. How is X-tra Lube Grease better than conventional off-the-shelf greases that you might find at your local auto parts store? Well, it's better because it's significantly better performing in just about every essential area. That's really the bottom line there. And so that, my friends, is the overview of the new X-tra Lube Grease. We are really happy with this formulation. We feel like it is really going to do a great job for our customers. And so that is that. If you have any questions, then by all means let me know. And with that, this concludes our training on the new X-tra Lube Grease. Thanks very much for joining me.